The gas mileage for Peter's car is 21 miles per gallon when the car travels at an average speed of 50 miles per hour. The car's gas tank has 17 gallons of gas at the beginning of a trip. If Peter's car travels at an average speed of 50 miles per hour, which of the following functions F models the number of gallons of gas remaining in the tank T hours after the trip begins? Two ways to tackle this. We see some variables in the answer choices. We also have that same variable in the question. So plugging in strategy from the old SAT actually works here. So we'll show you that, and then we'll think about it abstractly, putting together an equation from the word problem. But I think this one's easier plugging in. So let's pick a T here. So let's say 2 hours. So we want to know which of these expressions represents the amount of gas left over. Well, let's find out how much gas he has left over. If he's traveling for 2 hours and he's traveling at a speed of 50 miles per hour, then D equals RT, where D is distance, R is rate or speed, and T is time, will tell us that he goes 50 miles per hour for 2 hours, or 100 miles total. Now, he gets 21 miles per gallon, and he's gone 100 miles. So we want to figure out how many gallons Peter's used. So we're going to divide the 100 miles by the 21 miles per gallon, and we will get 4.762 gallons, which means this is how much he's used over those 2 hours. So we need to then subtract this from 17 to see how much is left over. So now we'll do 17 minus 4.762, and we get 12.238. Now we go to the choices and we plug in our T, and we see which one gets us 12.238. So let's look at A. In fact, we can even do one step quicker. These two right here, 17 minus some quantity. This minus quantity better be 4.762 in order for this whole thing to equal 12.238. So that's a little bit quicker. So we're going to do 21 divided by, got to be careful with our parentheses here, divided by 50. Actually, let's do this. 21 divided by parentheses 50 times 2, close parentheses. 0.21, no, that's way too small. We can get rid of A. How about B? So 50 times 2 is 100. Divided by 21, yeah, 100 divided by 21 will get us 4.762, which then when we subtract from 17 will get us our answer. We always double check. We always check all 4 choices when you're plugging in, just to make sure you don't get any copies or repeats. If you did get a copy, if you got more than one choice that works, you just have to plug in a new number. I can just look at this, though, and tell it's not going to work because we're dividing the entire thing by 50. We're going to get something that's going to be way too small. In fact, this one's going to be negative. 17 minus 21 times 2 is 17 minus 42. It's a negative number. That doesn't make any sense. And the same thing for D. So the only one that makes any sense here is B. Now, that's the plug-in way. I think that's easier. What if we wanted to do it probably the way they intend, which is to set up an equation and derive the equation from the word problem? Well, we know we're looking for the amount of gas used, and we know it's going to be 17 minus some quantity. So right off the bat, I would be pretty confident getting rid of C and D. But since we're finding out how much gas is left over, we're going to subtract whatever we use minus the 17. So again, we need to figure out how much do we use. Well, we're traveling for T hours at a speed of 50 miles per hour. So I again can find the distance. It's just going to be 50 times T. Now that number of miles, when you divide it by the miles per gallon, will tell you how many gallons you use. So again, we're going to get 50T. We're going to divide it by the 21, and this should tell us how many miles per or how many gallons of gas we use. And note that this matches up exactly with choice B. As I mentioned previously, this is a question that's similar to what you'd see on the old SAT in terms of being able to plug in. So this one, I mean, the one wrinkle is the speeds, rates, and times, and the whole miles per gallon thing, which may be a bit tricky. That's a bit different, so we might have to focus a bit more on D equals RT and other problems like this. But otherwise, it's a plug-in question. I think it is easier by plugging in. Take these abstract quantities, make them into real quantities by picking numbers, and seeing which choice gets you the answer. I think it makes this one a little bit easier. But yeah, this is a pretty standard question for the old SAT and apparently the new one too.